Good day to you all, students. Today we are going to discuss part 7 of chapter 15, Waves. So we are going to study about Doppler effect today. What is Doppler effect? It is the apparent change in frequency of sound due to the relative motion between the source and the observer. Doppler effect is a wave phenomenon. It is applicable to sound waves as well as electromagnetic waves. You know very well that sound waves need a medium for its propagation, and electromagnetic waves do not need a medium. Electromagnetic waves can travel in vacuum also. So, Doppler shifts occur irrespective of the presence or absence of a medium. We can analyze Doppler effect in three situations. So the first is when the source is moving and the observer stationary. Second, the observer is moving and the source is stationary. And the third situation, both source and observer moving. Now let us see what all this means. So first case, when the source is moving and the observer is stationary. In the diagram, you can see on the left side a line marked O. So that is the position of the observer. Then towards the right, you can see S1. S1 is the initial position of the source. And then you can see a waveform with a V marked there. So O stands for the observer. You can imagine a person standing stationary on the platform of a railway station as the observer. The source is the engine which is lying on the rails. So if the source moves, it will move with a velocity Vs. Now this engine will emit a whistle of frequency nu and velocity V. So that will be the velocity of sound. So we have three things here: the observer, the source, and the sound emitted by the source. So here observer is stationary, so his velocity is 0. The source will be moving, so its velocity is Vs, and the whistle emitting a sound has a velocity V. Now the distance between observer O and the first position S1 is marked as L. And then S1 moves towards S2 with a velocity Vs in a time t0. So the distance between S1 and S2 is velocity into time, that is Vs into t0. So let us explain this once again. Imagine a person standing on the platform of a railway station as the observer. The whistle emitted by the engine of a train is the sound wave emitted with a velocity v. The source is the engine moving with a velocity vs. So the velocity of the observer is 0 because in this particular situation the observer is stationary. Velocity of the source is vs and velocity of the sound emitted by the whistle is v. And the sound has an angular frequency omega and a time period t0. Now, as per sign convention, we take the direction from observer to source as positive because it is the direction of the speed of sound, whistle, the sound emitted by the whistle. At a time t equal to 0, the source is at S1. So the source emits a crest which reaches the observer in a time t1 given by L by V. That is from the formula time equal to displacement by velocity. Now distance moved by source from S1 to S2 in a time t0 is Vs into t0 as I explained earlier. Distance from S2 to observer, that is the second position of the source to observer, will be L plus Vs t0. At S2, the source emits the second crest. So time taken for the second crest to reach the observer from S2 to O will be T2 equal to T0 plus L plus Vs T0 by V. And at time n times T0, the source emits the n plus 1th crest, which reaches the observer in a time Tn plus 1, given by Nt0 plus L plus N Vs T0 by V. So in this time interval Tn plus 1, we have Nt0 plus L plus N Vs To by V minus L by V. In this time interval, the observer counts n crests and he records the period of the wave as capital T. What is period of the wave? It is the time taken for one wave to reach him. So if the time taken for n waves is given above, then the time taken for one wave will be dividing the above equation by n. So time period T equal to Nt0 plus L plus NVS T0 by V minus L by V divided, the whole thing divided by N. And on simplification, we get it as T0 plus Vs T0 by V. And frequency, you know, is 1 by T, time period, or it is the reciprocal of time period. So nu equal to nu 0, 1 plus Vs by V to the power minus 1. So if you apply binomial expansion, then the power minus 1 is changes to minus inside the bracket. So we get nu equal to nu 0 into 1 minus Vs by V. Here nu stands for the apparent frequency as heard by the observer, and nu 0 stands for actual frequency of the sound emitted by the whistle. Vs is the velocity of the source and V is the velocity of sound that is emitted. So in the first case here A, we considered the source S1 moving away from the observer towards S2. But if you consider the source S1 moving towards the observer in the opposite direction, then his velocity Vs will be replaced by minus Vs in the above equation, and we get nu equal to nu 0, 1 plus Vs by V. So when the source moves away from the observer, he hears the sound as a lower frequency, and if it approaches him, he hears it at a higher frequency. So this apparent change in frequency of sound due to the relative motion between observer and source, this is called Doppler effect. So now let us see what is the second situation. In the second situation, we have the observer moving but the source stationary. So we have to give a velocity for the observer as VO. But the source is stationary, so the velocity is 0. And the velocity of sound emitted by the whistle is V. So the speed with which the wave approaches the moving observer, it is the relative velocity, is V plus VO. And the time interval between the arrival of the first crest and the n plus 1th crest, as you saw in the previous cases, Tn plus 1 minus T1 equal to Nt0 minus NVO T0 by VO plus V. This is the time interval for n waves. So the time interval for one wave is given by dividing that expression with n. And when you divide it with n, we get the period of the wave. Period is time taken for one wave to reach the observer is T0 into 1 minus VO by VO plus V. And you can write it as T0 into 1 plus VO by V to the power minus 1. So this will be the time period. Therefore, frequency will be given by nu equal to nu 0 into 1 plus Vo by V. So this is the apparent frequency when the observer moves towards the source. And obviously, when the observer moves away from the stationary source, that Vo will be replaced by minus Vo. Now, the third situation, we have source and observer moving, but all three, that is the source, the observer, and the sound, we consider as moving in the same direction as the direction of the sound that is emitted. So O1 is the first position of the observer, O2 is the second position, and the velocity of the observer is Vo. S1 is the first position of the source, S2 is the second position of the source, and the velocity of the source is Vs. Now the source emits a whistle of sound wave which has a velocity v, that is also in the same direction, and under these conditions we will derive a general expression for Doppler effect. So I will repeat initially. Let the velocity of the observer be Vo. Velocity of the source is Vs. So observer and source are moving in the same positive direction of the wave emitted. At a time t equal to 0, the source emits the first crest of velocity v, frequency nu, and period t0. The observer is at O1 and the source is at S1. Distance between O1 and S1 is L. Since the observer is moving towards the source, the velocity of the wave relative to the observer is v plus Vo. Therefore, the time taken for the first crest to reach the observer is T1 equal to L by V plus Vo. Since the observer is moving towards the source, the relative velocity is V plus Vo, and time taken for the first crest to reach the observer is given by T1 equal to L by V plus Vo. This is repeated here. At a time t equal to t0, the observer has reached O2 and the source is at S2. So the observer has traveled an additional distance VOTO and the source has traveled an additional distance VSTO, and the relative velocity is Vs minus Vo. So at S2, the source emits the second crest, and the time taken for the second crest to reach the observer at O2 is T2 equal to T0 plus L plus Vs minus Vo into T0 divided by V plus Vo. And n times To, you get the n plus 1th crest reaching the observer. The time is Tn plus 1 equal to Nt0 plus L plus N Vs minus Vo into T0 by V plus Vo. So in a time interval Tn plus 1 minus T1, we have a minus T1 to the above equation, which is minus L by V plus Vo. So here in this expression, the observer counts n crests, and therefore the time period is given by dividing the just above equation by n. And you get the time period t equal to t0 into 1 plus Vs minus Vo by V plus Vo, which can be simplified to T0 into V plus Vs by V plus Vo. This is the time period. Therefore, the frequency is obtained by reciprocating the above equation. So nu equal to nu 0 into V plus Vo by V plus Vs. This is the general expression for Doppler effect. Here nu stands for apparent frequency heard by the observer. Nu zero stands for the actual frequency of the sound emitted. V stands for velocity of sound emitted by the whistle. VO is the velocity of the observer and Vs is the velocity of the source. So if the observer moves in the opposite direction, VO will be replaced by minus VO in the above equation. And if the source moves in the opposite direction, Vs will be replaced by minus Vs in the above equation. So using this general expression, you can derive apparent frequency for any movement of source or observer in any direction. Let us listen to some applications of Doppler effect, a short video.
Following the example of the animal world, man has also learned.
Sorry. So let us conclude the chapter. Thank you, students. Good luck and God bless.